YouTube, what's up? So we're encroaching on day number 2 of the 2023 admissions for the SHSAT. What is up, SHSATers? Who's out there? So we're going to go over hopefully the last part of the multiple choice Form A questions. There's about 10 of them I didn't cover still, and we'll just work from there. All right, so let me jump right into this so that we can get it over with and you guys can have sleep. I am still going to cover other parts of the handbook, probably stuff from Form B. There's the whole extra grid-in section, and I will at some point do the SHSAT 9 questions, all right? All right, please like and subscribe, people. If you guys need to contact me at the bottom, especially for SHSAT 9, after this point, I'm going to have a few less students, so I can take on a few more students, especially SHSAT 9ers. There's still another month until the exam. So, yeah. All right, let me flip the screen here. Let's see, where are we? And we'll jump into this. So let's see, where did I end up leaving off at? Let me see if my tablet's fired up. I should have done that before I started the stream. Sometimes the tablet doesn't talk to the computer. Okay, there we go. All right, so 104, we're going to start at 104. This formula, which formula? This one right here, can be used to determine P, the number of pages that will be in a book that contains W words. So P is dependent on W with an average of R words per page. So we have this fraction here with 1 over the R, and F extra pages in the front for the title and the publishing information. So this is basically how they're computing something. I guess they're producing a book. If the formula is solved for W, okay, so that almost means everything else here kind of doesn't matter. But let's give the words a shot. If the formula is solved for W, it can be used to find the number of words in a book with P pages. What will the formula be if it is solved for W? So that is all they're asking us to do. So everything else here is kind of irrelevant unless you're the person who's actually computing these pages. But as basically a test taker, kind of the storyline is fine. It's cool. It's awesome. But it's not what we're trying to solve here. So these are the choices. Let me change the color of the pen because I already did some stuff there. Let's make it dark green. So we're going to solve for W. So it seems to me that we're going to leave this term alone and we're going to get rid of this term. So we're going to subtract F from both sides. All right, so this goes away. And now we have P minus F is equal to basically W over R, right? That's 1R times W, so that's the same as that. So to solve for W at this point, we have to multiply both sides by R. That cancels. So this becomes that. Okay, so often this form here, this is the answer. Often that is not able to be found in the answer choices. However, in this case, it's right next to what I wrote here. So sometimes they will give an answer, especially when the answer is symbolic, that does not look like the answer that you got when you did the simplifications or solve for the whatever. That's all they're asking you to do here, solve for W. They gave the formula, solve for W. The rest is kind of fodder, okay? So that's all they're asking for there. So this really was not a hard question. Just let me make sure for verification purposes that 104 actually is E. Yes, 104 is E. All right, because I don't want to put my foot in my mouth here completely and totally screw up, right? So 105. And let me just make sure we're live isn't doing that. Yep. There's a few people in the lobby. Hello, welcome. Anybody catching this replay, you can pause the video as I'm solving these and see if you get the same answer, and then see my answer immediately right after that. Okay, this one confused a lot of my students. It is multiple step, and and that not part there, where at the end it says not, that whacked a few of the kids. So let's see here. A shipment contains 170 small boxes of medical supplies. So we have 170 boxes. Okay, we're up to there. And a random sample of 20 of these boxes, 8 have damage and the others are undamaged. So that means 8 out of the 20 are damaged. And if we want, we can simplify that, right? So we can divide by 2, we get 4 out of 10, or even 2 out of 5. I don't know if they want a decimal answer here, right? Because we haven't actually gotten to the literal conclusion of what they're stating here. So this so far is sidebar information. It may or may not be useful. So I'm just giving extra because normally this is where the questions go to. So we're up to here. That also means, by the way, that if 2/5 of the damaged, that 3/5 is the undamaged, right? Based on this sample, so this is our sample right here, 8 out of 20. Based on this sample, what is the best prediction of the number of undamaged boxes in the shipment? Not including the boxes in the random sample, okay? So enough students do 170 times, they figure out that 2/5 and 3/5 thing, okay? So it's going to be times the 3/5. And again, you could be using, instead of that, you could be using the 12/20ths, which just is going to make your math uglier and harder. Whoops, 12/20ths, I wrote 200. So anyway, it's times 3/5. But the problem with the 170 is that's no good. We have to take off the 20 boxes from the sample. It says at the end, not including the sample. So what we have to have is 170 minus the 20 gives us 150. And it's the 150, right, that we're going to try to apply the 3/5 to. So times 3 divided by 5. 5 goes into here 30 times. And then we have 30 times 3 is equal to 90. All right, so 105 should be C. Okay, and that's pretty simple. These are word questions, so trying to map the English to the math. And again, there's multiple steps to most word questions. So they can get annoying. They can definitely get annoying. Okay, the next one, 106, is even busier. And again, if anybody has any questions about what we're talking about, please ask. I'd love for this to be interactive. And if you have something that is not about what I'm covering, toss it out anyway, and I can get to it at the end if it's appropriate. Somebody posted a problem for me to solve the other day that was not on the SHSAT, and it was really a calculus question. That's not where we're going in these sessions. So make them appropriate, and as well as just general questions about the SHSAT. You can toss in at the end, and if there's time at the end, I'll do it, or I'll just address it at the next session. I normally run these about an hour, and it depends what I end up talking about on the problems here. Hopefully I can get to 114 in one swoop. If there's a problem that sticks out, I might separate it, or if I take too long talking, I might split this into 2 sessions. But my goal is to get this done by today so that you guys have something to work with during tomorrow. Okay, so in basketball, we're doing 106. A player earns 1 point for making a free throw, and 2 points. So we have 1 point for a free throw, and 2 points for making a basket. 1 free throw, 1 free, 2 basket. Okay, we're up to here. Marcus makes a mean of 8 free throws per game. Okay, that means that's his average. His arithmetic average per game is he does 8 free throws. And he scores at least 25 points per game. Okay, sounds like a reasonable player. The inequality below shows this relationship. Oh, yippee-yi-yay, they're going to show it to us, right? So let's try to figure that out before we continue. 2B, where is that coming from? It told us that it was 2 points per basket. That's what I wrote over here. And his average was 8 in the free throws. So each of those is worth 1 point. So basically it was 8 times 1, and they're just 8 times 1 is 8. So he scores a total of at least 25 points per game. So he's scoring 25 or more, right? So that's what the inequality here says. That the number of his free throws, right, and his points per basket is going to be greater than that on average. So that's an equation showing his performance. Okay, so let's read the words. The inequality below shows this relationship, where B represents the number of 2 points per basket Marcus makes. Awesome. What is the number of 2-point baskets Marcus needs to make? Well, B, they told us here, represents the number of 2-point baskets. So that we're trying to solve for B then, is what's going on here. What is the number of 2-point baskets? What is B that he needs to make to score at least the minimum for a game and make his mean number of free throws? So all we have to do is solve that inequality. So let's just do it. We have 2B plus 8 is greater than or equal to 25. I'm going to subtract 8 from both sides. And I get 2B. We keep the sign as greater than or equal to. And 25 minus 8 is what? 17, is it? Yeah. So that means we have 2B is greater than or equal to 17. We need to get B by itself. We're going to divide both sides by 2. And we get B is greater than or equal to 8.5. All right. So that means he needs to make 8.5 2-point baskets. Well, he can't do that. So he either needs to do 8 of them, or 9 of them. So the question is, which one are they trying to look for us to get the answer to be? Well, he's over 8. And to be over 25, so if he only does 8, right? So let's plug it in. If he does 8, right, we get 16 plus the 8. So we get 24. So if he does 8, he's not greater than or equal to the 25. So that means he has to do 9, right? If he does 9, he gets 18 plus the 8, which is 26. So therefore, the only one that it's going to work is F, right? The actual answer is 8.5, but when we plug that back in using the goal here is to be greater than or equal to 25. The only one that works is the 9. All right. So we had a problem 2 questions ago where the word problem almost distracted from the algebra. But in this case, we need the word problem to actually support the algebra. Otherwise, we don't know what to do with that 8.5. All right. So that becomes important. All right. Anybody have any questions about this? These are the kind of questions that are awkward and have little nuances to them that are unobvious because they're algebra. Okay. Give me 1 second. I'm getting a text message that all I have to write is okay to. All right, let me come back to here. All right, please like and subscribe, people. So that's that one. The next question is 107. So Nadia paid $1 to mail a letter. Okay. So she pays $1. to mail a letter. The cost to mail a letter is 55 cents for the first ounce plus 15 cents for each additional ounce. What is the weight in ounces of the letter? So we could subtract off the 55 cents here from the dollar, and we get 45 cents. So this is the first ounce, and this is the others. So if each one after that is 15 cents, really what we have to do is divide this into here, right? And we end up getting 3 as the answer. Okay, but that says, what is the weight in ounces of the letter she mailed? This is 3, right? This was for the first ounce. This was for the others. So she has 3 others plus the first ounce. So therefore the answer is 4. All right? So that's the way of doing it logically and kind of splitting down the algebra, if you will. We could have also viewed this a slightly different way, which is that we could have had, let me change the color of this just for clarification purposes. If we think it through more algebraically, $1, she paid $1 for the letter, so $1 is going to give her what? Okay, it would have been 55 cents for the first ounce plus 15, that's a 5. I don't know why it looks like a 15. And then plus 15 cents times the number of ounces minus 1. All right? So if we run that through, we get 1 is equal to the 55 plus 0.15 times the ounces minus, and then the 0.15 times the minus 1 is 0.15. All right. So if we work on the 0.55 and the 0.15, right? That's 0.55 minus 0.15. So we get, what do we get there? 0.30 plus 0.15 of the ounces. And we are gonna, now we have 1 is equal to that, because that was the whole price of that there. Something tells me I made a mistake here. Let me just double check this. What did I do here? The number of ounces minus 1. That's going to give me 70. 55. No, this is 40. All right, that was my mistake, because I knew if I now have the 1 is equal to 0.40 plus 0.15 times the number of ounces, I'm going to subtract the 0.4 from both sides and get 0.6. In my head, I was seeing the 0.7 when I had the 30. So 0.6 is equal to 0.15 of the number of ounces. And at this point, we divide both sides by the 0.15. And we get 4 is equal to the number of ounces. So on this one, we've built in the first ounce thing, right? The one down here in the red, I had to add the 1 at the very end. But I had accommodated for the 1 right here. I'm circling that right now. So that's our algebra. Both are fine. And the thing about the algebra here is we used all the real numbers. We were solving for ounces, but the rest made sense in terms of what the equation was. All right, so that's that question. That one wasn't too hard. but it did require setting it up properly. Most students forget to add that ounce in if you did it the red way, and the green way is easier once it gets set up, but getting it set up is a barrier to a lot of students. Okay, 108 uses a table, so I'm going to look at the illustration first. The number of oranges. As soon as I see a table like this, where it's comparing 4, 6, 9 to different prices, I think two things: either a linear equation and or constant of proportionality. So I'm not sure where they're going here. I just see some obvious stuff. So I can do some computations if I want, but I'm going to look at a little deeper. I'm going to go to the words first because I don't know which is asking me to do yet. The table shows the cost of oranges. What is the unit rate for the cost per oranges? So there's a value in all the choices, and no choice says not enough information, or no choice says undefined. So that means because it told us unit rate, this is about a relational proportion or the constant of proportionality. They're telling us that, right? That's what unit rate means. There's going to be a constant of proportionality here. Otherwise, there's not a unit rate. Okay. Remember, we're dealing something with y equals kx. Okay, k is the constant of proportionality. It means when x increases, y is going to increase at the same rate. What rate? K. So that's our unit rate. Okay, so that hint is telling us there's something in here that needs to be true. So if I notice this 4 oranges at $1.80 each, does that say? Yes. So if I divide that by 4, and 4 is the same as 2 times 2, what I'm going to do is divide this by 2 and get 90, and divide it again and get 45 cents. That's per orange. Okay, so that should also be true for 6. Or another way to look at it is if I go from 4 to 6, I should be adding 90 cents. So $1.80 to 270, that works. And then if I get 9, right, what I'm going to have is I can double the 4 and get 8, which is 360. So 360 plus 45 cents gives me the 405. So we can confirm here that we're understanding the question, we're understanding the hint, and the actual data in this table works. And by the way, even though this is the constant of proportionality, we can use the same techniques that we use for the slope. So let's prove this a different way. So if the slope is going to involve doing something like the change in y over the change in x, right? Which means subtracting the two y's, y2 minus y1 over, and respectively x2 minus x1. We can do that here. So if we have $1.80 or 270 minus $1.80 over 6 minus 4. Okay, this is 90 cents over 2, and that is equal to 45 cents. So we've proven the unit rate by doing this as well. And we can pick any of these. We can pick the 4 versus the 9, right? So we can do, where's some space here? Down here. We can do 405 minus the $1.80 over 9 minus 4. And when we do that computation, we're still going to get it's equal to 45 cents. So we're proving that the constant in all cases is going to be the same. All right. So with all that kind of background in mind, just to give a heads up for those of you who weren't quite clear how to solve this or what it was about, this is kind of what you need to think about as you're processing and looking and interrogating and critical analyze and the whole thing of all these kind of questions. So again, we have the cost of oranges. We figured out the unit rate was 45 cents. Okay, and it says, what is the unit rate? So then the answer is obviously E. So this comes down to, I just took a couple of minutes to explain it, but this is a pretty couple-second problem. It's telling you it's a unit rate. So all you have to do is calculate it, okay? It would have been nicer if they gave us 5 oranges and 10 oranges, because those are, to me, easier math to do in your head. But at least they gave us reasonable numbers, that the heads up was $1.80 divided by 4 is 45 cents. That's a no-brainer to do. And we could do it for the others. We could also do something like, if you want, 405 divided by the 9. And that's, again, so there's all these different ways to help us along doing this, all right? So a few people in the lobby. Yo, what's up? Welcome. Don't be afeared. Be good for this to be interactive. Okay, 108. We're getting closer to 114. Okay, a softball player bought bottles of water for her team to practice. Awesome. What a nice person. The total number of bottles, B, is proportional to N. B is proportional to N. And N is the number of players at the practice. Which equation represents the relationship between B and N? The constant of proportionality is P. So everything I just talked about for the other question is the case. So a constant of proportionality doesn't look like this, it doesn't look like this, it doesn't look like this, right? It's the Y equals KX, and they're telling us that the P is the variable. So let's try to make sense of this. If she bought bottles of water for the team, and the total number of bottles she bought was B, right? I'm going to put tot here for total, right? B is proportion to N, the number of players. So N is, you can't use P because P, they already told us the constant of proportionality was B. So I'm going to put number play. So if she does something like buys 5 bottles per player, then if there's 10 players, she bought 50 bottles. That's B. If there's 1 player, she bought 5 bottles. Or brought. She had to buy them in the first place unless she ripped them off. All right? So that's all we're looking at here. That's literally what this means. Okay? And it tells us B is proportional to N. B is proportional to N. So remember a second ago I said if we have Y equals KX on the other question, that if Y goes up, if X goes up, then so does Y. So we have the same thing here. B is equal to P times N. So if N goes up, then B goes up. If N goes down, B goes down by the same unit rate, which is P. All right, so that's your constant of proportionalities. Again, this was a big part of grade 7, but it still seems to blow a lot of students' minds. B, C, and D are just involving addition. Those could appear to be the right thing, but this is a direct relationship. And we can see it worked with the bottles again. So if she brought 1 per player and there's 5 players, she bought 5. If she bought 100 per player, that's 5 players, she bought 500 bottles. It's nothing too critical or deep going on there. Okay, the last question, the number 110, is also tricky to a lot of students. And there's probably 2 ways to do this. Let's see here. Malik earns $10 per hour at his job. He wants to change to a job that pays $12 per hour. Okay. What will be the percent increase? Percent increase in Malak's hourly pay if he makes changes, if he makes this job change. Okay. So there's a formula, which is it's the new minus the old over the new. Okay, you could also do new minus the old over the old, but they're asking us to compare it to the original price. Okay, so that would mean in this case, we would get 12 minus the 10 over the 10, and that's equal to 2 over 10. All right, and that's equal to 20 over 100. And any percent means divided by 100, so then our answer is F there. Okay. Okay. There is another way to solve this. It's still the same way, but it's just kind of different numbers, which is that if we want to kind of write this out and say 12 is X percent of 10. Okay. In which case we can set up a proportion that it's X percent is equal to 12 over 10. And we could use the cross product. So we get 12 times 100 equals 10x. Okay, that's 1200 equals 10x. And therefore 120 is equal to x. All right, so at that point, it basically means 120%, right? X being in this case, because that's what we were solving for, X percent. So X percent is going to be equal to X over 100, because that's what percent means. And we're saying we got 120 over 100. Now, the original price, the $10 an hour, that was the original 100%. All right, so if we take that and subtract 100% from here, the percent increase then, because we're dealing with the difference there, is going to give us 20 over 100. So we have two different ways to solve this to try to get the same answer. One is just straight up using this formula, which is basically just a shortcut to what I did in the green. But they're both handy because you can do a computational error. So it's nice to be able to use either one to be able to try to figure that out. All right, anybody have any questions about that? All right, we're at 110, so let's go to 111. A rain gauge shows that 10 centimeters of rain fell yesterday. If 1 inch is equal to approximately 2.5 centimeters. So this is my ratio. This is my unit rate. This is indirectly a constant of proportionality, although that's not really what they're testing in this question. So how many inches of rain fell yesterday? Well, 10 centimeters fell yesterday, right? We're going to put the 10 at the bottom because we have inches to centimeters. 10 centimeters is going to be what? X inches, okay? And we can do the cross product if we want. This one just leaves out at me, but let's go through it. We have 1 times 10 is 10, and that's equal to 2.5x. Divide both sides by 2.5, 2.5, and we end up with C. All right, just straight up simple unit conversion, and they pretty much gave us the conversion to us. So that's kind of a no-brainer-ish. So this is involving a ratio, involving a proportion. It is a unit conversion, but they're telling us how to do it. So it's kind of not really a unit conversion question. But you should still know, if you happen to have flipped this and did 2.5 over the 1, the reciprocal of that, then the only way to solve this would to be also take this and do the reciprocal. In other words, 10 over x, right? That's the same way. There also, we could have done 10 is the 2.5 as, where's the number? No, I wrote that wrong. We could have done 1 is to x as 2.5 is to 10, right? 1 inch is to x inches as 2.5 centimeters is to 10 centimeters. So this also is a question of scale then. Basically, the ratio is our scale factor. So that's another way to look at that. All right, so awesome. Awesome, dude. Okay, 112. The height of a plant in millimeters, do we have to do a conversion? Is proportional to the number of days the plant has grown. Up, heads up, constant of proportionality, right? So the height of a plant is proportional to the number of days the plant has grown. All right, that's one way to look at it. All right. What is the constant of proportionality? So here we slaps us right in the face in millimeters per day. So if H equals PD, then P is equal to H over D. Okay. So they're giving us some of those numbers. So we get, what do we have? The height was 20 millimeters. And by the way, this is 20 millimeters, that's millimeters. So there's no unit conversion, everything's in millimeters. So the height is 20 millimeters. And the number of days is 8. All right. And we get, we can simplify that or whatever, but we get 8, we get 2, 16, we get 8 and 4/8. So that would give us 2.5, because that's the only choice they're giving us to consider with this. All right. It does say it's a proportion, right? So we could have almost gone straight up into this. It's a proportion. It says the height. Let me change the color of that just to make the English clear. If we remove words, it says the height is proportional to the days. That should leap out at you guys that that's what they're asking you to do. The height is proportional to the days. All right, so that's 112. Nothing too deep going on this page at all. So that wasn't too bad. Okay, once again, proportional relationship. I mentioned this before earlier, but we also have unit rate. And if they mention constant of proportionality. So which table shows a proportional relationship? So this is similar to the question over here, even though 112 involved it. This one here with the table with the oranges, where I did that thing where I computed the slope, if you will, even though the constant of proportionality is not using that same kind of thing, you can still use that technique, right? That's one way I verified the unit rate. Because in a linear equation, when we have the y equals mx plus b, right? The b, if we view the y equals kx, okay, that's just a line, and then the b gives an offset to it. So this is interesting because if we have a coordinate grid And our exemplar is a line that basically goes through the center. It goes through 0, 0. So what the B does is, if it was like +5, we would have a parallel line that would be there. So this line here, if you will, it might be y equals mx, right? This line here, if it was offset 5, would be y equals mx plus 5, right? In each case, we would have a value for the m, obviously. All right, so that's what's going on there. So if you notice what I just explained, the exemplar line without the offset, it's going to go through 0, 0. So that's often when we get to a question like 108, and especially like the 113. That's a big heads up that we're trying to look for. And there was another question, I think, earlier in this exam. It may have been in the grid-in section where it involves that. So that's one of the heads up that we're trying to look for here. So the fact that this exists means B can't be the answer, because it should be 0, 0. And the fact that this exists means C can't be the answer either. Okay? Now, choice D does have a 0, 0, but so does A. So just a heads up, the 0, 0 does not guarantee a proportional relationship. Okay? This still needs to be a line. We still need to verify that this is a line. Okay? So we can use the techniques that we know based on what we're saying here. So one example is here. This the same as 1.5, obviously. Okay, so it meant that y changed 1.5 and x changed by 4. Okay, can we show that same thing here for the next two? Well, 3 minus 1.5 is also 1.5, and 8 minus 4 is 4. So this is definitely a proportional relationship, because everything's consistent, and it also goes to the 0, 0. So A seems to be the answer. So let's go to D and try to rule out D. All right, and if you notice, I didn't even bother to solve 1.5 over 4. I don't care. They both ended up with a 1.5 over 4. So they're constant. And just like we did earlier, let me just show you, change the color here to be clear on it. If we use the first one and the last one, we're going to get 3 minus 0 is 3. And at the bottom, we're going to get 8. Well, that's what 1.5 over 4 is. If I multiply the numerator by 2 and the denominator by 2, we still get 3/8. Or if you want, even on this one, I could divide this by 2. If whatever I do to the numerator, do the denominator. So I would also get 1.5 over 4. Voila. So again, as long as there's a proportionality, there's a unit rate, there's a proportional relationship, all of this always ends up being true. So let's try to discredit that on the choice number D. So again, we just can't say, oh, look at that there. Okay, so anyway, we have 12 on the top, and 4 minus that gives 4. So if we simplify it, we get a unit rate of 3. Okay, if we do that for here, we get 4 over 4, and that's equal to 1. That's not the same. Okay, right? And we can even compare this to this, which gives me 16 over 8, and that's 2. So everything is helter-skelter here, and there is no unit rate on D. So the answer here is A. That's what they're looking for. This is a classic constant of proportionality question. It's technically unobvious. And by the way, if you didn't know about the 0, 0 thing with the constant of proportionality, all the stuff I did on the right-hand side for A and all the stuff I did on the right-hand side for D, well, that's sufficient by itself. Right? As long as we can keep getting the same unit rate, we don't really care if it mentions 0, 0. In other words, this choice didn't need to be there. We don't need to see that to verify that that's the case. All right, but we do need 3 points. We just can't compare two XYs against each other. We need the third one to make sure that it's consistent, because we don't want something, if we were to graph it, that might be like this, and then all of a sudden flatlines or something, right? So we're looking for something that would truly be that, all right? That kind of a thing. All right, and then finally, we are at 114. All right, so Terry wants to pour cement around the edge of a circular patio in her backyard. So let's do that. Let's draw a circle. Why the heck not? Okay, we'll put a center. Okay, the patio has a radius of 5 feet. Let's fill it in. R is equal to 5. Let's make I'm going to make it an uppercase R just so it's more prominent. We're up to here. What is the distance in feet around the edge of the patio? So what they're asking for is the actual circle. That's the perimeter of the circle. A perimeter of a circle is also known as its circumference. And you should all know your formulas by now. They're not going to give it to you. It's 2 pi r. And we just were told that it's 2 pi, and the radius was 5. So we get 5, and that's equal to 10 pi. And now they're saying use 3.14 for pi. So that's equal to 10 times 3.14, and that's equal to 31.4. And we get F, and we live happily ever after. We get the top score ever in the history of the SHSAT, and booyah, booyah, booyah. All right, any remaining questions? So we got through the grid-ins, we got through all the multiple choice for Form A, and I also did the grid-ins for Form B already. So what I might do, maybe even later today, is do some multiple choice from Form B, or the grid-ins, or the SHSAT 9. There's no way to complain here. All right, any last questions? There's still people in the lobby. Please like and subscribe. Why am I begging? In any event, I'm Greg from GregsTutoringNYC at gmail.com. Hit up my website, GregsTutoringNYC.com. There's a whole bunch of sections on it. Actually, I can bring it up here. If you scroll down, there's a whole bunch of links I have, test dates, a whole bunch of links, handy stuff. Go to SHSAT Facts, this line here, click on that, and there's a whole bunch of different things. I have past handbook reviews, so if you scroll down a little bit, let's see, where do I have that? And I have topic lists and all these other things about formulas, things about geometry, things about products you should know during your exam, a study guide. This hardest math problem is hundreds of questions there for you guys to use from all the different grade levels. So wherever you're stuck at, just start up and go for them. Anyway, if you come down to this walkthroughs here, this is the cover to cover, which is part of the series that we're doing now. This one's about the 2023 handbook, but if you click on that, it has also. So this here is the ones I've done this past week for you guys, all right, for this year. But if you notice, there's one for the 2022 handbook, there's one for the 2021 handbook, and there's one for the 2017 handbook. All right, so there's hundreds of hours of video here, all right, or at least a lot. The 2017 I have 15 hours worth. This one I have 22 hours worth. This one I have doesn't say, just says hours. So there's a couple of dozen hours. I don't know where I got hundreds from, but I do have hundreds of videos on the channel. And again, you can get those by going to where? Right here. Where do I have my channel listed? I may have it listed above. Anyway, it's Greg's Tutoring at NYC.com/videos. Yeah. All right. Also, like I said earlier, after the weekend, I will no longer have so many students, and I'll be able to take on more. I do tutor for other exams. I have some of them listed here: the TACHS, the CHSEE, the HSPT, the ISEE, the SSAT, the PSAT, etc. The Bergen County Academy test. There's a ton of them. It's a lot of fun. I enjoy doing it. So hit me up. Yeah. Peace out, everybody.